We'll start in a minute. Okay, today we'll continue with the review of sections 10.1, 10.2, and 10.3. And maybe we'll get started on section 10.4. On Friday, we were working on this problem, find the arc length of the curve. It turns out that I wrote down the wrong y value. The y value that I wrote down is the derivative of this y with respect to t. So what I really want for y is t over 4 plus 1 over 3t to the third. And then to find the arc length, we find the derivative of x with respect to t. The derivative of 1 over t with respect to t is just negative 1 over t to the second. And the derivative of y with respect to t is what I wrote down for y, which is 1/4 minus 1 over t to the fourth. Okay, then square each of those. When we square the derivative of x with respect to t, we get 1 over t to the fourth. And when we square the derivative of y with respect to t, we get 1/16, and then minus 1/2 times 1 over t to the fourth plus 1 over t to the eighth. Okay, when we add those, we'll get a common denominator. Oh, for now, I'll just write down what we have. 1 over t to the fourth plus 1/16 minus 1 over 2t to the fourth plus 1 over t to the eighth. And the least common denominator is going to be 16t to the fourth. So that means I would have to multiply 1 over t to the fourth by 16 over 16. So 16 times 1. And then this one, multiply the numerator and denominator by t to the fourth, so plus t to the fourth. And this one, multiply the numerator and denominator by 8, so I get minus 8. And then for the last one, I have the wrong denominator. I need t to the eighth, not t to the fourth. So Well, I need more space. I'll rewrite that real quick. So the common denominator we want is 16t to the 8th. So this one, multiply the numerator and denominator by 16t to the 4th. Multiply this term by t to the 8th. Multiply this one by 8t to the 4th over 8t to the 4th. And then the last one, 16 over 16. So we get this, and if we put it in standard form, we get t to the 8th plus 8t to the 4th plus 16 over 16t to the 8th. And in both the numerator and denominator, we have perfect squares. So the one in the numerator is t to the 4th plus 4 quantity squared. And in the denominator, we have 4t to the 4th quantity squared. And so for the length, this is the quantity that goes inside the square root. So the arc length for values of t from 1/2 to 1. And then the square root of this, let's just write down what we get when we take the square root of this. We'll get t to the 4th plus 4 in the numerator and 4t to the 4th in the denominator. So this will be pretty easy to evaluate. T to the 4th divided by 4t to the 4th is 1/4. And then 4 divided by 4t to the 4th is 1 over t to the 4th, but I'll write it as plus t to the -4. So let's just take it a couple of steps further for the arc length. We get the antiderivative 1/4, and then plus t to the -4 plus 1 divided by -4 plus 1 from 1/2 to 1. I missed the t again, so an antiderivative of 1/4 is 1/4 t. And we'll write this as minus 1 over 3t to the 3rd Okay, so we're almost done. At the upper limit, 1/4 times 1 is 1/4. Minus 1 over 3 times 1 to the 3rd is minus 1/3. And then from that, we will subtract 1/4 times 1/2, which is 1/8. And then minus 1 over 3 times 1/2 to the 3rd, which is minus 1 over 3 times 1/8, or 1 over 3/8. So 1/4 minus 1/8, that's gonna this part is gonna simplify to 1/8. And let's go ahead and write the rest, minus 1/3, and then plus 8/3, because 1 divided by 3/8 is 8/3. So we get 1/8 plus 7/3, or 59/24 for the arc length on that one. Okay, let's move on to the surface area problem. Find the surface area generated by revolving the parametric curve about the x-axis. So if that curve is also a function of x before it's parameterized, so suppose y equals capital F of x is the function for which this is the parameterization, then the surface area is the definite integral from a to b of 2 pi times capital F of x, not plus, but times the square root of 1 plus capital F prime of x squared dx. This is a formula that we've seen before, and when we transform it using the parametric equations, we get the definite integral from alpha to beta, where alpha and beta are t values, and then 2 pi times g of t times the square root of the derivative of x with respect to t squared plus the derivative of y with respect to t squared dt. Our g of t is what y is equal to. Y is equal to t plus 1 over 4t. And alpha to beta will be from 1 to e. Okay, so we have to find the derivative of x with respect to t. Since x equals the natural log of t, dx dt is just 1 over t. And then the derivative of y with respect to t, this is going to be 1 and then minus 1 over 4t to the second when we take the derivative of 1 over 4t. So let's go ahead and square those and add them. Okay, when we square 1 over t, we get 1 over t to the second. And then square the quantity 1 minus 1 over 4t to the second. So we'll get 1 and then minus 2 over 4t to the second, which simplifies to 1 over 2t to the second. And then plus 1 over 16t to the fourth. Okay, when we add those, the least common denominator is 16t to the fourth. So we'll write the denominator 16t to the fourth. We have to multiply 1 over t to the second by 16t to the second over 16t to the second. So we'll have 16t to the second in the numerator. This one, we get plus 16t to the fourth. And the next one is 8t to the second minus 8t to the second. And then plus 1. And when we simplify, we get 16t to the fourth plus 8t to the second plus 1 over 16t to the fourth. This is what goes inside the square root, and this is a perfect square, so let's write it in factored form. 16t to the fourth plus 8t to the second plus 1 is 4t to the second plus 1 squared. And the denominator, 16t to the fourth, is 4t to the second squared. Okay, this is what dx dt squared plus dy dt squared is. It's going to go inside that square root. Well, we can write down the surface area integral. It ranges from 1 to e. 2 pi rg of t is t plus 1 over 4t. And then the square root of this is just going to become 4t to the second plus 1 over 4t to the second dt. So I'll leave the rest of this for you to do. I guess what I would do is simplify this 4t to the second plus 1 over 4t to the second to 1 plus 1 over 4t to the second, and then multiply the two polynomials, and then afterwards just integrate term by term. Afterwards, it's pretty simple to do. Okay, so make sure that you memorize the arc length formula and the surface area formula. Okay, we'll look at some review problems from 10.2. This first part, find a Cartesian equation for each polar equation. So up here I can write the basic equations to remember. R to the second is x squared plus y squared, where x is r times cosine of theta, and y is r times sine of theta. And let's see. What else do we have? The tangent of theta is y over x. Okay, so for this first one, r to the second equals 7. So just replace r to the second with x squared plus y squared equals 7. So we're using the Cartesian coordinates x and y to convert this polar equation into a Cartesian equation. So that's all we have to do with this one. What is this x squared plus y squared equals 7? Yeah, it's a circle with radius square root of 7 centered at the origin, 0, 0. Okay, the next one, 18r equals 9 times cosecant of theta. Cosecant of theta is 1 over sine of theta. So we can write this as 18r equals 9 over sine of theta. So the goal is to write an equation in the variables x and y with no more thetas and no more r's. So any idea on what to do next? Yeah, multiply both sides by sine theta. So we get 18r sine of theta equals 9. And we can divide both sides by 18. So we get r times sine of theta equals 1/2. And r sine of theta is what y is. So we just get y equals 1/2. Okay, the next one, r equals 5 times cosine of theta. Multiply by r. Did you say r? Sounded like r. Yeah, I would multiply both sides by r. So multiply both sides by r, we get r to the second, and then r times 5 cosine of theta can be written as 5r cosine of theta. And then we replace r to the second with x squared plus y squared, replace r cosine of theta with x. So we get x squared plus y squared equals 5x. What kind of equation is this? This is also an equation of a circle. It's not in standard form. If we subtract 5x from both sides, so incidentally, this is the satisfactory equation for in Cartesian coordinates. But if you subtract 5x from both sides, I'm going to leave a little bit of space between that term and plus y squared, that equals 0. Then if we complete the square on x squared minus 5x, so we take half of -5 and square it. So half of -5 is -5/2, and when you square that, you get positive 25/4. So I'll add 25/4 to both sides. And then the left-hand side, we can write this as x minus the quantity, I should say the quantity x minus 5/2 squared plus y squared equals 25/4. This is the standard equation of the circle centered at the ordered pair 5/2, 0 with radius 5/2. So I'll just make a note of that. This is the circle. The center is 5/2 for x and 0 for y, and the radius is the square root of 25/4 or 5/2. Okay, the next one, r squared equals sine of 2 theta. So I'll do half of it. The left-hand side, r squared, that's x squared plus y squared. You do the other half, sine of 2 theta. So I'm thinking of a famous identity for sine of 2 theta. There are any number of identities that a trigonometric expression can have, but there's one that's really nice for this. sine of 2 theta. Sine of 2 theta is equal to 2 times sine of theta cosine of theta. This can be derived, I'll just mention, you can think of sine of 2 theta as sine of theta plus theta, and then use the identity for sine of alpha plus beta, in this case, to come up with sine of 2 theta. All right, well, let's see. What can we do now? Since y equals r sine of theta is y divided by r. We'll have to figure out how to get rid of r after doing that, but that's at least one thing we can try. And then we'll replace cosine of theta with x over r. So x squared plus y squared equals 2. Replace sine of theta with y over r. Replace cosine of theta with x over r. Now what? So we can write this as x squared plus y squared equals 2xy over r squared. So replace r squared again with x squared plus y squared. So that's a Cartesian equation. You can leave it like this, or you can multiply both sides by the quantity x squared plus y squared. And if you want, you can write it as the quantity x squared plus y squared squared equals 2xy. That's good enough. Okay, one more of these where we find a Cartesian equation for the polar equation. R equals 12 divided by 4 times sine of theta plus 7 times cosine of theta. Yeah, multiply both sides by 4 sine of theta plus 7 cosine of theta. Okay, so we'll get r times 4 sine theta plus 7 cosine of theta equals 12. So what good does that get us?
Distribute the r into that equation and directly replace both of those components with x and y.
Okay, yeah, distribute multiplication by r, rearrange the factors a little bit, and we can write 4r sine theta plus 7r cosine theta equals 12. And then replace r sine of theta with y, replace r cosine of theta with x. So we just get 4y plus 7x equals 12. 4y plus 7x equals 12. The graph of that in the xy plane is a straight line. So okay. Let's do a little bit of calculus. Find the slope of the line tangent to the curve r equals 2 times cosine of theta, where theta equals pi over 6. Okay. So So find the slope of the line tangent to the curve r equals 2 times cosine of theta, where theta equals pi over 6. So in order to find the slope of the line, we need to know what the first derivative is, and then evaluate the first derivative at a certain number. So remember our formula dy dx. So the derivative of y with respect to x, since x and y are parameterized, the numerator is the derivative of y with respect to theta, divided by the derivative of x with respect to theta. So here we're using y equals r times sine of theta, and x equals r times cosine of theta. For the particular r equals 2 times cosine of theta. But first we'll write down the formula for the derivative. And then afterwards we'll replace r with 2 times cosine theta. And then after that we'll evaluate it when theta equals pi over 6. Okay, so if y is equal to r times sine of theta, where r itself is a function of theta, we have to use the product rule, right? R is a function of theta multiplied by a function of theta, sine of theta. So the derivative of y with respect to theta is, by the product rule, the derivative of r with respect to theta times sine of theta plus r times the derivative of sine of theta, which is cosine of theta. And then in the denominator, the derivative of x with respect to theta, we write the derivative of r with respect to theta times cosine of theta, and then plus r times the derivative of cosine of theta with respect to theta, which is negative sine of theta. So we'll write, since we're adding a negative, we'll just write minus r times sine of theta. Okay, this is our derivative formula, the derivative of y with respect to x, when x and y are defined parametrically with coordinates r of theta. Okay, so we have a couple more things to do. In this formula, we're going to replace r with 2 cosine of theta, but we also have to replace the derivative of r with respect to theta, where r equals 2 times cosine of theta. So I'll rewrite r equals 2 times cosine of theta, and dr d theta is negative 2 times sine of theta. So for this particular curve defined by r equals 2 times cosine of theta, or derivative of y with respect to x. So replace dr d theta with negative sine of theta, but we're going to multiply negative sine of theta times sine of theta, so I'll just write negative sine of theta squared. And then we're going to add that to r times cosine of theta. So we're going to add 2 times cosine of theta times cosine of theta. So I'll just write plus 2 times cosine of theta squared. Okay, that takes care of the numerator. Then in the denominator, the derivative of r with respect to theta is negative 2 sine of theta we're going to multiply that by cosine of theta, so we get minus 2 sine of theta times cosine of theta. Then we're going to subtract r times sine of theta. So r is 2 times cosine of theta, so we're going to subtract 2 times cosine of theta sine of theta minus 2 times cosine of theta sine of theta. We can simplify in the denominator because those are like terms. If you want to simplify it a little bit, we can do that. So negative sine of theta squared plus 2 times cosine of theta squared. And in the denominator, negative 4 sine of theta times cosine of theta. And then the last thing we do is we evaluate this derivative when theta is pi over 6. So at theta equals pi over 6, the derivatives evaluated at that point will give us the slope of that tangent line. Okay, so when theta is pi over 6, sine of pi over 6 is 1/2, and so we're going to square 1/2 and take its negative. So this will be negative 1/4, and then plus 2 times cosine of pi over 6 squared. Cosine of pi over 6 is the square root of 3 over 2. And so when we square that, we get 3/4. And we'll work on the denominator for a second. So in the denominator, negative 4 times sine of pi over 6, that's negative 4 times 1/2, times cosine of pi over 6, which is the square root of 3 over 2. So let's see. So in the numerator, negative 1/4 plus 6/4 is 5/4. And in the denominator, negative 4 times the square root of 3 over 4 is just negative square root of 3. Are you getting the same numbers?
I just have one question. On your dy over dx, the negative sine squared, should that be negative 2 sine squared? For the,
In the numerator?
yeah, for the dr d theta.
What, this one?
Yeah. Yeah. It's like your dr d theta is negative 2 sine.
So dr d theta is negative 2 sine,
So then when you plugged it in,
and I'm missing a 2, is that what you're saying?
I think so.
Yes. Yeah, I think I agree. Yeah, up here, I'm missing a factor of 2, so this should be minus 2, because dr d theta is negative 2 times sine of theta. So this one is negative 2 again. So if I just multiply this by 2, this just becomes negative 1/2, right? Yeah, so this will be negative 1/2, and then plus 3/2. I'll write it again below that. I think we're okay in the denominator. So dy dx, so this is negative 1/2 plus 3/2 divided by negative square root of 3. So negative 1/2 plus 3/2 is just 1, so we get negative 1 over the square root of 3. You can write that. This is an okay answer, but you can write it as negative square root of 3 over 3. So that's what I get for the slope after that correction. Okay, here's another polar curve to graph. So sine of 4 theta. So if you write 0 is less than or equal to 4 theta, which is less than or equal to 2 pi, and then divide each of the three parts by 4, that tells you the length of each period for that function. So the period of sine of 4 theta is from 0 to pi over 2. So what we'll do is we'll sketch a graph of that equation in Cartesian coordinates. And then we'll use that graph to graph the polar equation. So between 0 and 2 pi, we have 4 periods of this function. So this will be pi over 2, pi, 3 pi over 2, and 2 pi. And between 0 and pi over 2, we're going to subdivide that into four subintervals of equal length. Each one will be length pi over 8. So we subdivide each of those. So this number is pi over 8, then 2 pi over 8, which is pi over 4, then 3 pi over 8, 4 pi over 8 is pi over 2, 5 pi over 8, 6 pi over 8 is 3 pi over 4, 7 pi over 8, 8 pi over 8 is pi, 9 pi over 8, 10 pi over 8 is 5 pi over 4, then 11 pi over 8, 12 pi over 8 is 3 pi over 2, 13 pi over 8, 14 pi over 8 is 7 pi over 4, and then 15 pi over 8. Okay, so r equals 3 times sine of 4 theta, so the amplitude is 3. So we're going to, I'll just hit the high points and the low points and the points on the theta axis. Okay, then we get 4 periods of this function. Okay, now we will use this graph to help us graph the polar equation. So I shouldn't tell you what I'm going to try to do, because then when I do it and don't do it, okay, so we're going to subdivide from 0 to 2 pi in increments of pi over 8. So if I attempt to do the pi over 4 first, looks like I'm off already. Dang. Okay, there's pi over 4. But then in increments of pi over 8, we cut those in half. Just one more. Okay, then start when theta is 0, r is 0. Then between theta equals 0 and pi over 8, the r value goes to 3. So we have half of a loop, 3 units long. Then between pi over 8 and pi over 4, we go back to 0, or the origin. Then between pi over 4 and 3 pi over 8, that's up here, but the r values are negative, so they have to go in the opposite side, which is going to be from here down to there, if that has length 3. Okay, then from 3 pi over 8 to pi over 2, that's up here, the r values are still negative. So it's going to go back to 0 at pi over 2. Okay, so that gets us 1/4 of the way, and we already have 2 loops. So we still have 3 more periods left. Okay, now from pi over 2 to pi over 8, the r values are positive again. And we're going to end up at 5 pi over 8, the r value is 3. So it's going to go up here, if this is 3 units from the origin. Then between 5 pi over 8 and 3 pi over 4, the r values are positive, and they're going to go to 0 again by the time we get to 3 pi over 4. Okay, then between 3 pi over 4 and 7 pi over 8, the R values are negative, so the graph will be on the opposite side of the origin. And we're going to end it right about there, say. Okay, then from 7 pi over 8 to pi, that's this part, but the R values are negative. And so the R values are going back to 0 when we get to pi. So each of those loops are supposed to look like the other ones. They don't quite look the same, but hey, we're halfway between 0 and 2 pi. We're up to pi now. Okay, so from between pi and 9 pi over 8, that's this region. And the R values are positive. So when we get to 9 pi over 8, the R value is 3. Then from 9 pi over 8 to 5 pi over 4, that's this region. The R values are positive, but when we get to 9 pi over 8, when we get to 5 pi over 4, it will be 0. Okay, then 5 pi over 4 to 11 pi over 8. That's this region right here. But the R values are negative. So the graph will be in this portion. Something like this. Okay, then between 11 pi over 8 and 3 pi over 4, the R values are still negative. But by the time we get to 3 pi over 2, the R value will be 0 again. Okay, just one more period to go. Between 3 pi over 2 and 13 pi over 8. Between 3 pi over 2 and 3 pi over 2 and 13 pi over 8, the R values are positive. So the loop will be down here. And then between 13 pi over 8 and 7 pi over 4, the R values are positive, but when we get to 7 pi over 4, the R value is 0 again. And then between 7 pi over 4 and 15 pi over 8, that's this region, but the R values are negative. So that's going to put us on the opposite side over here. And then the last part, from 15 pi over 8 to 2 pi, that's this region. The R values are negative, so the graph will be on the opposite side of the origin. And we get that. So 8 loops. Oh, we're out of time. I lost all track of time. Okay, tomorrow we'll just start the section 10.4, but that's all for today.